Giants.
That's right. Okay, so let's do another one. Ready? One last example. What if... Aha! Oops. That didn't work. Yes. What if there's a happy little river and it's moving, let's say 8 meters per second downstream. Alright, now Mr. Shoes is awesome, and he can paddle at 16 meters per second. But Mr. Shoes gets in the river down here, and he's going to paddle upstream at 16 meters per second. Now, relative to, let's say, Mr. Paganelli, who's sitting reading a book underneath a palm tree.
Reading a book? I don't read.
I'm sorry, he's using his iPad to read a book.
There you go.
Relative to Mr. Paganelli, how fast is Mr. Shoes going?
8 miles.
Yes?
8 meters per second.
He's going 8 meters per second. Now, what's velocity for Mr. Shoes?
8 meters per second that way.
Okay, 8 meters per second that way. Good. Now, on the other hand, Mrs. Shoes is also going to canoe, and she paddles at a relatively steady speed of 8 meters per second. And she's going to paddle downstream and meet me in the middle.
She's going to crash
Yes?
into you.
Now, relative to, let's say, Mr. Paganelli, how fast is Mr. Shoes
16
going?
meters per second to his right.
Okay, she's going 16 meters per second downstream.
He's sitting like this. It's going that way.
Yes? Right? So, if I'm going 8 meters per second upstream and she's going 16 meters per second downstream, if we combine our velocities, how fast are we meeting each other? 24 meters per second is how fast we're coming together. Correct? So, if we started out, let's say 96 meters apart, how long will it take us to meet?
4 seconds.
So, see, all of you got only 50% on that one, because you have to do the formula. Because time is distance over speed. Distance is 96 meters, all over what?
24.
24 meters per second. Right? So what's 96 divided by 24? 4. Now here's a question. How do you get seconds out of meters over meters per second?
Seconds moves up.
Yeah, you have to multiply by seconds over meters times seconds over meters. So the meters factor out. Seconds, you're left with seconds. Weird. Did you get that? So 4 seconds. Which brings me to another last thing, factor labeling. You guys have done it before in math class, and now you're really going to have to do it instead of just pretending.
Yeah. But we all love factors.
Everyone loves factor labeling. So the question was, Mr. Shoes said, okay, if we're going 25 miles per hour, how fast in that is miles per second? That's the question. And in order to do that, you cannot change the quantity of what you have. You can only change how you present that quantity. Okay, Gary King? All right. So, when you have 25 miles per hour, it really is 25 miles per hour. And in order to change it to the type that you want, you have to multiply it by a factor of 1. So we want to go to seconds. We want to get rid of hours. If hours is in the denominator, where do we have to put it to get rid of it? Mile? In the numerator. Okay, it's half done. That's good. So hours are up here, and we're going to seconds. Which is bigger, an hour or a second?
No, I got you into minutes.
Which is bigger, an hour or a second?
Hour.
Hour's bigger. So, the 1 always goes with the hours. 1 hour. How many seconds in an hour?
3,600.
3,600.
90,000.
Right? And so that's going to take us to miles per second. And what that looks like, just for everyone's sake, I'm going to write it fully out. 25 miles times 1 hour. And that's all over hours times 3,600 seconds. Well, we can see that hours factored out. So that's 1 over 1, right? So 25 miles times 1 is going to be 25 miles. And 1 times 3,600 seconds is 3,600 seconds. So 25 divided by 3,600 is what?
0.0069444444.
0.00069?
No, 0.0069.
0.0069?
Yes.
Oh dear.
Are you gonna simplify fractions?
0.0069 miles per second. Okay? So that's that. So that's factor labeling. Make sure you know how to do that. It could get even worse though. What if on the other hand, we wanted, let's say, oh golly.
Miles per centimeter.
Let's say the Notre Dame quarterback threw for 70 yards per minute, which is not really good.
500 yards.
Right? And the question was,
Oh, Mr. Shoes.
what? How many centimeters is that per second? Oh golly.
Oh.
So we have to figure it out, right? So we had 70 yards per minute. Well, I know I want to get to seconds, so I'm going to get rid of minutes first. Minutes to seconds. So that's 1 minute over 60 seconds, right? And how do we get from yards to centimeters? Well, let's go to inches, shall we?
Sure, 36.
We do that? Okay, so yards are down here. There's 36 inches per yard. How many centimeters per inch?
Oh, no, 2.14.
2.54.
2.54.
I got the 2.
2.54 centimeters equals 1 inch.
Yep.
There are very few conversions that I'll have you memorize. And that is one of them. Write it down, that's a good one. 2.54 centimeters per 1 inch. That one is actually exact versus a lot of other conversions that are not exact. So when you're doing sig figs, that one is exact. Right, and so that will, if you take a look at it, minutes factor out, yards factor out, inches factor out, and we're left with seconds per centimeters per second. So you multiply through 70 times 1 times 36 times 2.54, all divided by 1 times 1 times 1 times 60. So 1 divided by 60.
106.68.
So what is it?
106.68.
106.7 centimeters per second. And everybody's happy. Now, if this was velocity, what else would we need?
A direction.
A direction. Question.
2 questions.
Yes.
Will we ever have anything that's like something per 2 seconds?
Sure, yeah. Mm-hmm.
And then you want us to put it in the answer in decimal, or can we?
Decimals. I like decimals.
Yay!
Don't like fractions. That's a good question.
Something.
So when you do these problems, don't forget to put in the formula, put in the units, keep track of units. Okay?